Alright, welcome back generals to another Let's Fix Generals 0 hour to make the best game ever. Okay, so last video we started implementing the ASM matcher. We laid out the data structures, and as I finished the video yesterday, I had one more idea, and that is ASM matcher. So it's a matcher type. So here maybe we do not need to make a copy of the ASM instruction. Instead, we just put a pointer to it. Yeah. ASM matcher. So I could say the result will, well, creates a runs a comparison on the given function match. The returned results will retain a dependency on the function match, on that function match objects. Yeah, so what we can do is here, we don't make it a copy, but we make it a pointer. This way, the structure becomes much smaller, and basically it will simply link to the ASM instruction here. Yeah, you can do that. I mean, it means if that match was destroyed, then this would dangle. But, well, just don't do it. Just keep it safe. All right. Good. So we got that. Then we can go to our ASM matcher and think about how we implement this now. Oh, okay. Good. In our results, we want to add lines and is matching. Okay. Okay, so instructions. Okay, so I mean the label thing will be kind of simple. Okay, let's do a stupid implementation first. How about that? Stupid implementation. Yeah, maybe that's the way to go. So stupid implementation. Stupid. So for size t, I equals 0, size t, let's do I0, I1 equals 0. Okay, let's do const size t count 0 is instructions.size and count 1 is instructions 1.size. Good. So for I0 smaller than count 0 and I1 smaller than count 1. Yeah, I think this is already a pretty good loop condition, right? I mean, certainly we want to loop. We want to loop these things as long as either of these, wait, or. Yeah, let's do a while. While this is smaller than this and this is smaller than that. Yeah. Okay, and we don't, well, we can already put down here the plus plus thingies. But it will probably be a bit different. Okay, so while either of these is smaller than the count, we keep on looking. Okay, then we will have instruction 0. We will access our instructions, right? So we access this guy and this guy, right? So what does it return? ASM instruction EX. So we call this instruction 01 const. Okay, and then what do we do now? Instruction instruction dot address. Okay, let's worry first about the label thingy. So label. Okay, so okay, let's say if instruction 0 label if not empty or that not empty, then to continue here and result dot lines dot and place back is a matcher type, so we want to put a label. So we put label if label if not well we just label, hold on, I think label label also needs to be array. Labels, label pair. Well, why don't we then use std pair? You could use std pair. First, second. String is fine. Better than pair. Good, so it's label pair. Label pair. So 0 equals label. We could also make it a pointer. This here. It's 80 bytes. 80 bytes? What the hell? Why is it? Ah, okay. Okay, let's also make it pointer. Const. So we make it label, instruction label. Yeah. Okay, and then place back lines. Does this work? Oh, I see. Well, we got some jank down here. Well, this will crash, by the way, now. Effectively. Redundant codes. Oh, there we go. By the way, let's remove this here. This will definitely crash, but for testing, that's fine. So I just want to see if it actually ends up here in our lines variant vector. So we have label, pair, with main, yeah. So these match, that's good. I mean, labels, we don't really compare. If they mismatch, it's fine. Okay, so lines. Yeah, okay, that works. Yeah. Index 0, yeah. So the variant saves the type, so with the index, and the label, ASM label is the first type. Yeah, and then we continue. Okay, but now we have an infinite loop basically. Yeah, that's fine. Good. I think we need to say if instruction label, if not instruction label empty. Hold on. Instruction. We don't stop here. Like we still have work to do. Like there's more information in our instruction. Yeah. Okay, so we say next. Okay, instruction 0. We say so we have the most interesting thing is the text, of course, but we also have this invalid jump. How do we deal with that? Yeah, I guess we can check those things first. So if condition dot is invalid is not, does not equal this one invalid, then we definitely have a mismatch, right? Is match true, or is matching? Is matching true? Okay, that's our assumption. It's matching. So, but if this is not identical, then is matching is false. Likewise, else if instruction 0 dot is jump is not is jump, then is matching is also false. yeah, else if instruction dot is jump or instruction one is jump, then we can have another condition here. If instruction 0 dot jump len well, we can say, we can put this in here. And we say else if jump len is not jump len, then also is matching equals false. Okay, so if the invalid instruction, which obviously should never happen, but if this is not matching, then we have a mismatch. If one of these is a jump and the jump is not identical, then it's not matching. Or if the jump len between these is not matching, then it's also not matching. And else, yeah, then the next thing is to compare the actual instruction. And here we can get fancy. Okay, else if instruction 0 text does not match this text, then also is matching false. Okay. So if not is matching, well, yeah, if not is matching, well, let's say if is matching, else not matching. So if is matching, then we put here ASM match. Well, we already have a match here. Well, let's call it ASM label. ASM match. So ASM match dot instruction pair 0 equals instruction 1 dot, well, static cast to static cast instruction 0 ASM instruction. Pointer const. Yeah. And the same for instruction 1. Okay, and then mplace back. ASM match. Good. And then here we have ASM mismatch. And here, you can also say is matching here result dot is matching is false. Okay, and then we will also have something here for ASM matching instruction pair, which we need to, which we can check later. Okay, so that would be like the first super simple draft, which doesn't yield, which will not yield the best results, but it should yield some result, and it still crashes. Hold on. It still crashes. Yeah. Can we make it not crash? So the problem is one instruction list can be shorter than the other, right? Let me see. Okay, what we need is a dummy instruction, I think. So we have ASM instruction as empty instruction. Yeah, and that will be here. Empty instruction is a matcher. Let me see. Empty. We need to initialize it. Oof. How do we initialize it? Do we need a constructor? create null instruction. How about that? Then we just create here instruction. Instruction dot address equals 0. Instruction is invalid is false. Instruction is jump is false. And I think that's it. Yeah. Return instruction. And then we use that and call here create null instruction. Wait, does this actually work? No, we can't call functions on statics. Or can we? Probably only const expand. I'm not sure. Am I retarded? I think I'm retarded right now. What is the complaint here? A non-static data member may not be defined outside its class. Oh, it's not static, right? Oh, this actually works. Somehow I thought it wouldn't, but it does. Okay. Interesting. Good. So this should work. We have an empty instruction. So what we say is, we say if I0 is I0 is smaller than count 0, then we do this. Otherwise, no. Otherwise, empty instruction. All right. Wait, what's the error here? Oh. Aha. Hold on. We need to create a null instruction X. There we go. Good. Null instruction X. No problem. We got this. Okay. X. There we go. X. Good. So this is X. And X. Good. Okay, this works now. Great. Good. And then we say if I1 smaller than count 1, then we take this. Otherwise, also the empty instruction. So this means that now our iteration on either side can go beyond the boundaries of this list, of this vector. And if it is, then it just has an empty instruction, which by default mismatches with anything on the other side, right? Because it doesn't, like the text is empty, so it will automatically mismatch. So it will always end up here, but that's fine, as desired. Yeah, so this should work, and we can happily count these up until oblivion. it's fine, right? Or is there some problem maybe? I think it will work. Let's see. Let's make a test run. Create null instruction X place. Yeah. Okay. Okay, so the second count is 455 and the first 56. Okay. So we have here a bunch of stuff. And place back is mismatching. It's matching true. And the text is not the same. Push ECX. Doesn't match this one. It's matching false. So it goes here. Here's a mismatch. And then here. Lines, mismatch. Is matching false. Yeah. Good, and then it just counts up. Okay, let's put a breakpoint here. Let's see how it runs through. And it does run through. Okay, let's see. Lines 495. Does that make sense? 495. Oh, that's unexpected. Actually, no, it's not unexpected because there are a lot of labels inside then. And labels are their own lines. Yeah, okay, it makes sense that it makes sense that it can be longer than instructions. Because the labels are its own thing now in here, right? So index 0 is a label, index 2 is an instruction. Do we have some jumps in here as well? So 2 is always mismatched. Do we have any matches here? No matches. Okay, so just labels and mismatches. Yeah. Well, the label actually So if I wonder if a label, I mean, if we have a label on one side but not on the other, technically it is a mismatch, right? It is a mismatch. Hmm. 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 I'm not sure. If we have left and right, ASM label on one side. Hmm. Hmm. Yeah, but hmm. Okay. I'm still not so sure about this instruction label thing. And I also realize that this is wrong. This here. This is wrong. Okay, we first need to figure out how we compare instruction properly. Yeah. Okay, we probably want to have a separate function for this. So static bool compare ASM text. So we have const std string left right. Maybe we should use left right naming consistently. It's easier than 0 1. No, it's okay. Left right. Okay. ASM text comparison results. ASM mismatch detail. I think we return this. Is a mismatch detail. On that note, to me it looks like that this one needs to be a single thing, and we just call it detail. Yeah. Okay. So we have this function here. Is a matcher. And then here we return. No, we don't return yet. Well, we will have detail, return detail. Yeah. Else if yeah, let's put this here. ASM mismatch detail. Let's mismatch detail. Mismatch detail. It's already initialized to 0. Good. Mismatch detail. Okay, and then we say else if mismatch detail equals compare ASM text instruction 0 dot text and instruction 1 dot text. What is the problem here? Then we put here mismatch detail dot instruction mismatch bits not 0. This is somehow not working. Oh, there we go. Yeah. So we compare ASM text here in the special function. We get a mismatch detail. Is matching false. Okay. And then here we can say ASM mismatch dot detail equals mismatch detail. Okay, so that is served. But now we need to implement this function, which will be interesting. Good. So we have left. Oof. Okay, I remember we created a function a time ago. In function, here, this one, split instruction text. Let's move this function to ASM matcher. Move this. Do a static. Then we go to function. Split instruction. Split instruction. Oof. Here, split instruction. Compare ASM text. Let's call this split instruction text. Ah, now I know why it's not finding it. There we go. Instruction text array. Array. Okay, I think this one we already tested and it worked. So that's good. Splits instruction text to array. Yeah. Okay, so the reason for this, then we can compare each individual component. And basically get a little bit more info. Yeah. Okay. How do we do this? Okay, so first we create this instruction array. Left. How about we call this? Let's call this text 0 and text 1. Text 0, text 1. Then we have array 0 and array 1. Good. So we have split instruction text, text 0. And the same for that. Text 1. Okay, so now we have these two arrays. And then we can we need a std string empty or just dummy. Let's call him dummy. Okay, here we need to do a similar like this here. Okay, now I realize this one doesn't tell us how much is actually in there. Doesn't tell us how much. instruction text. Hold on, what is this text array? It's an array. Huh? It's an array of strings. But yeah, we lose the information of this. Okay, let's put this here on the top. Okay, let's put a struct array with size. I don't know. Array with size. Then we put the. Let me see. Is there like a elegant trick? C++ array with variable size. That doesn't have. Yeah, vector, okay, but that's an allocation. I don't want to allocate, basically. Yeah, it looks like for now we need to accommodate our array with size. So we have a template, size t, size, and then we have this in here. Class T, or E for elements, E, size, size T, user size. Okay. Let's set this to 0. Array with size. Okay. Maybe we have a better name for this. Dynamic array. Dynamic array. Or let's say, well, dynamic fixed array. Sizable array. Sizable. Yeah, I have no idea how to name this. Okay, sizable array, and then we simply put that here with std string, and that. And here we say, hold on, we also need here array. Okay, sizable array, this, yeah. Okay, and then we put that here, split instruction. What's the problem again here? Ah, see. Good. So okay, so our instruction text array, we have maybe we call this inner. City array. Okay, so we have array dot inner dot size, array dot inner index, array inner. Okay, so index. Right, so array index. Okay, so index. Oof. Index. Okay, I think we can get rid of this guy here. And then no, let's use that. I think that's okay. Then here at the end we say array size equals index plus 1, right? So last index plus 1. Yeah, I should do. Okay, and this should now give us array 0 dot size and array 1 dot size. Yeah, so this is the actual use size, not the max size of the std array, but the use size according to this function here. Yeah. Okay, so this should work. And then we say, similar to what we did here, similar to this guy, we say std string word 0, std string word 1, I smaller this and this, and then we take array 0 dot inner this, otherwise takes dummy, and same here, array 1 I1 dummy. Okay, so far so good. And then we say if word 0 is not word 1. No, that's also wrong. That's also wrong. Because we cannot just compare the different words. We cannot just compare the different words. Because we cannot do it because in there will be some lock and unk and all this stuff. Sub and off. Okay, off sub. Let me see. Okay, I need some water. Okay. Okay. So, basically, we need to ignore the numbers that come after sub or off and so on. When we look at this thing, we cannot just go by the underscore because here are also underscores. Yeah, so we need to search for sub. Yeah. Okay, so let's collect these different kind of words. So we have sub and off and unk. Yeah, I guess that's all. It's sub, off, unk. Okay, so what we need to do is in function let's put in the function types. Define unknown func prefix sub unknown offset prefix unknown data prefix unc, right? Wait, let me see, what are offsets? Function. So sub is for functions, unc is for some data, I guess. I don't know what the difference between offset and data off and unc is, but okay. Okay, let's call this sub prefix, off prefix, unc prefix. Maybe that's better. Unknown. Maybe we put these things at the end. Unknown prefix. Or let's say just prefix sub of unc. Yeah, let's put it here. Okay, and then we can use these things. In function, we say so sub becomes prefix sub. Prefix sub. Hold on. Prefix sub. Prefix sub. Okay. Let's do the same for unc. Prefix unc. Okay. And off. Off prefix off. All right. But then we will also have off. Then we do this off. That's a bit hard to read. Okay. Okay, so we have off, we have sub, okay, and then unc, prefix unc. Okay. Okay, this should work correctly. Okay, let's compile this. Okay, good. So now we have defines for those keywords. And now, okay, now we need to be clever. Yeah, okay. How do we do this? Okay, so basically, we need a custom compare function. Yeah, custom compare. Okay, I think for starters, if word 0 dot size does not match word 0 dot 1 size, then it's definitely a mismatch, right? This is fair. Actually, no, that's incorrect as well. That is incorrect. Good. With that settled, let's go. So we need boah. Ja. Okay, we need something like while char 0. Wait, hold on. Let's do const char 0 equals word1 dot cstr and char1 equals word1 cstr. Okay. While char 0 is not null char or char1 not null, if okay, if includes strings.h, if str case compare, if 0 equals case compare, no, case compare is case compare L. Is there n case compare. I have no idea what just happened here. Okay, str in case compare char0 prefix sub I wonder if function types. I wonder if this instead should be const expr std string view. Is that already a thing here? Includes string view. String view prefix sub. Let me see. Prefix sub. Sub. Prefix sub. Yeah, maybe it should be like this instead. Prefix of prefix onc. Because then we also get the size here. Of onc. Okay, SC, and then we say here prefix sub. If 0 equals prefix sub, how about we make another type? std array of std string view 3 prefixes. Let's call them unknown prefixes, just prefixes. Okay, and that will be prefix sub, prefix of, prefix onc. And then we say for const string view prefix prefixes. And then if strn compares prefix sub prefix dot size dot cstr. Oh, hold on. Dot data. Dot data. Yeah. Okay. It's not zero terminated, but it doesn't have to be because we have the size. Yeah. Okay, this should work. So if this is the case, then we can also do the same for char1. Oof, this function is getting complicated. Okay, so there's a little bit of code duplication here. I mean, we could make it different, but I think it's fine. I think it's fine. Okay, while I think it can be and, why both are not at the end yet. Yeah. Yeah. Maybe. Okay, let's skip this party for now. Let's continue here. So if char 0 does not match char 1, then we have a mismatch. Actually, it should be or. Okay, if this does match, break. I realize maybe we just need one I. For now, let's just make one I. For now, let's just plus I0 plus I1, but I think it can be just one. Okay, so when these characters are not identical, then we have detail detail set one I0, right? Detail dot structure mismatch bits. Yeah. Break. Yeah. Okay, so I think this is correct, but of course we need to break. Yeah. Okay. And so if we have a prefix, if we hit a prefix, then we need char 0 plus equals prefix size. Yeah. So, no, that's wrong. Yeah. Okay, that's good for, but it is not all. Oof. How's this implemented here? Okay, so basically after this prefix, we need to also skip all hex numbers. So we will have char hex, and that will contain 1, 2, oh boy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A, B, C, D, E, F. 3. Well, do we really need an array? No. Create a new function. Static bool is hex. Is hex digits. Char C. And here we simply say return C is larger equal 0 and C smaller equal 9, Hold on, let's open an ASCII table. ASCII table. Oh boy. Good. 0 to 9, yeah, okay. Yeah. So it's either that or A to F, C larger equal A, and smaller equal F, or AF. Yeah, I think that's simple check. Okay, so while is hex digits SHA-0 plus SHA-0. Yeah. And then we need to copy this the same here with SHA-1. I think this will work. Yeah. Yeah. Oof. Okay, so yeah, I think this will work. Let's rename this to I, and then remove this one here. By the way, I hope we didn't rename this one, no? Okay, so I, and then we put it in here, and we name this I makes it a lot simpler. Yeah. Okay, this may work already. I mean, at least up to here. Yeah, let's put a breakpoint in here. Let's see if our algorithm is good or not. This will be interesting. Okay, so we have array, and in there are push ECX. And here we have push EBX. Okay, so basically now the mismatch detail should return bit 0 and bit 0 set to 0 and bit 1 set to 1. 0, 1. That should be the bits. So as a number, that would be 2. 2. So the instruction mismatch bits should be 2. Yeah. Okay, let's see. Dummy is empty, prefix. Good. So our 3 prefixes in here. Then we have array, size 2, 2, words, push, 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 push. prefix. Okay, now it goes through all the prefixes and checks if that compares, and it doesn't, so it just skips over. Okay, let's put a breakpoint in here for the case where we actually do hit it. Okay, and now it checks, okay, is this char not the same? It is the same, so it continues and checks the next one. Again, same story. It's quite a yeah, quite a lot of work, but it should be fast. It's okay. Okay, let's put a breakpoint in there in all the fail cases, pretty much. Oh, what happened? Oh, we are never incrementing char, right? Okay. Right. Char. Yeah. Let's do a 4 and increment it here at the end. Plus plus char 0 and plus plus char 1. Yeah. Okay, so here we have C doesn't match B. Okay, so we have a mismatch. Great. So it sets bits 2 exactly and break. Great. And then it will return that detail. Okay, that's good. Okay, let's check the next one. Next one is mof divert ptr, and here I have something completely different. Okay, so this should mismatch also on the second. Yeah, this should mismatch on the second. Let's see. Yeah. Okay, so this seems to work. Let's put a breakpoint in here to see if that gets hit ever, and it does. Good. Okay, off. There we go. So the prefix is off. So now this char should count forwards to the 9-3, and it does. 9-3. Good. And then it will count forward as long as it is a hex digit, which it is. It's a 9, so it should be true, and it is. Good. So this now counts forward until the whole number is exhausted, and then it should stop. Yeah, and now it's empty. Great. And now what do we have? We have the null chr and the empty string. So these clearly mismatch. Let's see what is instruction. It's mof eax offset, mof eax offset off. The null char. Well, is that really a mismatch? It is not, because it's just one side that doesn't know it. Okay, so it's a little bit of a problem. So one side knows the symbol, but the other side does not. How do we deal with that? One side knows the symbol, and the other side does not. Whew. Okay, I haven't anticipated this one. But yeah, that makes sense. How do we mitigate this? Sure. I don't know. Maybe ignore the rests. Ignore the rests. Yeah. Oh, it's an interesting problem. I have an idea, but I need to think about it a little bit more. Okay, what's the time? Hours. We are close to 2 hours. Okay, let's take a break here. Yeah, let's take a break and then maybe have one more session afterwards. Yeah. All right. I wish you a great day or night. Until next time. Goodbye.